This is Mohana again. Here we are going to discuss or learn about highest common factor. So when do we come across this term, highest common factor, or we can also call it as greatest common divisor? We came across it in arithmetic. In case of numbers, integers, we try to find highest common factor. So now let us try to learn something more about it. And we are going to try how to find highest common factor or greatest common divisor in case of polynomials. Now polynomials look a bit complicated, so we are going to try to find highest common factor. We naturally have different methods of calculating factors and different methods of calculating highest common factor in polynomials. We are going to explore all and we are going to learn how to do the best way. So first is through factorization. Factorization is the most simple method to understand. It's not at all complicated, it's very simple. But in case of polynomials, as the degree increases, it becomes difficult to guess all its factors. So it's not easy in case of polynomials. But in case of normal integers, this method is pretty comfortable. You express the whole digit in terms of basic numbers like 2 and you take the highest common factor out of it. But in case of polynomials, things get complicated. Let us try to explore it later as well. So the second method is division. So this division method you are all very familiar, in case of numbers. It's a bit too long and it becomes, clumsy in case of polynomials. It becomes a bit complicated. It occupies too much of space, time, everything. And we are going to explain that one also. So you can decide it for yourself which method you prefer. And now we are going to also learn how to calculate highest common factor through Vedic method. So now let us take a small example and try to understand what I exactly mean. So we are going to try initially to find through factorization. So when we try to factorize these quadratic, these are simple quadratic, so we get these factors. The first expression a square minus 12a plus 35 gives us 7 and 5 as roots. And second expression gives us 7 and 1 as root. So we have the common root here, that is a minus 7. So it is the highest common factor of both these quadratics. Now let us try to see how to do it through division as well. So initially I just wanted to understand the basic form of calculating highest common factor through division. So I just presenting an example of integers so that we understand the method. Here we are actually trying to find out highest common factor of 75 and 180. So when we are trying to do through division, we divide 180 by 75 and when we get remainder 30, with this 30 we divide 75. So whatever the previous divisor is, that will come into this dividend part. And we are going to try to do it and we get 15 as remainder and we are going to take our previous divisor 30 and we'll try to perform division. So we'll do this process until we get remainder 0. And whenever we get remainder 0, whatever is the last divisor will be there, that will be the highest common factor. So here in this case 15 is the common factor of highest common factor of both numbers 75 and 180. So this is just to understand basic method. Now let us see how it looks when you try to get highest common factor of two polynomials. So here we are trying to perform get highest common factor of aq plus 4a plus 4a. I think this is 4a square. Sorry for typo. Plus 4a plus 1 and a power 4 plus 3a cube plus 2a square plus 3a plus 1. So when we are trying to do it, we perform the division, whatever we get remainder, we try to deal with it. And then with that, whatever remainder we get, we again try to perform division. We will divide earlier divisor with the remainder what we got here. And we take out the common coefficient. So we perform that division till we get 0 as remainder. So now you can see whatever this last divisor is there, a square plus 3a plus 1, this is the highest common factor of this cubic and this polynomial of degree 4. So this is the method. Now, since we have learned the method, previous quadratics, whatever we took, we'll try to perform division and we'll try to understand that method. So we are trying to perform the division in the same way. We will get minus 4a plus 28, and when we get minus 4a plus 28, this is the remainder. So we perform one more division by taking the common term out and we take the earlier divisor. See, the previous divisor we are taking in the case of dividend and we are trying to multiply it with the remainder what we got. And we do it till we get 0. Okay. So finally we got 0 and this is the last divisor. So here highest common factor is a minus a. Now you can see the methods. The division method is pretty much complicated. It involves a lot of space, time, everything. And somewhere or the other you will get lost doing all those calculations. And for those who fear algebra, this is kind of nightmare. So you can do either through factorization if you can find out factors, or we can learn simply through a Vedic method, which is best of all. So now let us see what to do. Here in Vedic method, what we do is we simply subtract or add. We don't do any other operations and simply we get highest common factor. So we are going to subtract one equation from another and we got minus 4 plus 28. If you take common terms out, you get a minus 7 as factor. Now let us try to do addition. So when you try to do addition, we try to eliminate the coefficient, that is lowest term here. So in order to do that, we are going to, here it is 35. So in order to subtract, we are going to multiply, make by equation by 5. So that this 5 minus 5, when you try to multiply, it becomes, equal term. So when you add, this becomes 0, nullified, and you are left with minus 4 square plus 28. So whenever you get any solution, you take out all the common things out of it. So finally you get result a minus 7. So isn't this method simple and easy? So this is a method, you'll get through Vedic mathematics only. And you can easily get polynomial, highest common factor without any complications. And now let us see what is its exact principle. So if you take two expressions, the P and Q and S are expressions of polynomials and H is their HCF. So this factor is basically highest common factor is factor of both these expressions. So we have written in terms of factors. Okay. So this common factor is also factor of their, added polynomial or subtracted polynomial. So you can always find highest common factor is common of all the operations of P and Q. So now here we are going to add or subtract both the polynomials P and Q. If required, we are going to multiply them with coefficients like m and n for our operations. And finally, we are selecting these m and n in such a way that highest parts and lowest parts are removed and HCF appears. If you remember the earlier problem, so if you remember the previous problem, you can always remember that highest term, that is x square, and the lowest term, that is coefficient 1. Both are removed. And so we got HCF. Now let us, try to understand this procedure through some more examples. So let us take two cubics here. In other words, two polynomials. So we have 4x cubed plus 13x square plus 19x plus 4 is equal to 0. And the other polynomial is 2x cubed plus 5x square plus 5x minus 4 is equal to 0. Previous session, that is, how to find factorization of cubics, you have learned that there is at least one real root of every cubic equation. So if someone is really good at doing factorization through either Vedic mathematics or the other way, they can always do it through factorization. So when we do factorization, we get factors as 4x plus 1 into x square plus 3x plus 4. And also 2x cubed plus 5x square plus 5x minus 0 gives us factors 2x plus 1 into x square plus 3x plus 4. So now you can know that the highest common factor is x square plus 3x plus 4. Okay. But, it is a bit difficult to find out through factorization. Now you will learn how to do it through Vedic mathematics. So we are going to eliminate the highest part. So what we are going to do is, we need to eliminate this x cube term. So second equation, its coefficient is different. So we are going to multiply the second equation by 2 and then we are going to subtract from both. So when you do 4x cube term and 4x cube term get cancelled and you are left with 3x square plus 9x plus 12. So when you perform this subtraction, you get 3x square plus 9x plus 12 and if you take common term out, you are left with x square plus 3x plus 4. So this is our highest common factor, but we are going to confirm it doing again through other operation by eliminating the lowest term as well. So since here the lowest terms are same and the signs are also opposite, so we just have to add this. So we basically simply add and we get 6x cube plus 18x square plus 24x. Now we are going to take 6x out of it common. That is, we are left with x square plus 3x plus 4. So now you can see that here we got HCF in a simple manner, which is x square plus 3x plus 4. And this method is comparatively really simple, even more than factorization. Now let us see one more example. So we are taking polynomial of degree 4. So 6x to the power of 4 minus 11x cube plus 16x square minus 22x plus 8. And one more polynomial is 6x to the power of 4 minus 11x cube minus 8x square plus 22x minus 8. So we are going to try to find through factorization. We get these factors and we are trying to take common things out of it, and highest common factor what we get is 6x square minus 11x plus 15. So now we are going to try to find it the same through our Vedic math. Initially you will try to subtract, and if you observe, the highest term gets cancelled and the second term gets cancelled as well. And so we are left with 24x square minus 44x plus 16. We observe 4 is, can see the 4 is common and we divided by 4. So we are left with equation 6x square minus 11x plus 4. Now we are going to try to eliminate the coefficient, that is lowest term. So we'll just simply add. And the last two terms get, their signs are quite opposite and value is same, so they get eliminated on their own. And we are left with 12x power 4 minus 22x cube plus 8x square. And now we can see that 2x square is common here. So we are going to divide it for 2x square and we are going to be left with our highest common factor, which is 6x square minus 11x plus 4. So this subtraction or addition method is comparatively easier and simpler compared to even factorization, where we find the difficulty of finding the factors. So let us see one more example. Now here we can see that one is a cubic, other is a polynomial of degree 4. But we will always eliminate highest and lowest terms. So highest term is x power 4 here and lowest term is coefficient. So now let us see how we are going to do it. Anyway, we will come across this factorization. So you can always get these two factors and highest common factor is x square plus 2x plus 3. So now we will try to learn how to calculate this, Vedic maths. So we will take both of these equations. I have written these terms separately so that there is no confusion between their powers. Like you have x power 4, x cube, x square, and each and every term is different. And when you add these two equations, plus 9 and minus 9, that is lowest term, get cancelled. And we are left with x power 4 plus 2x cube plus 3x square. So x square is common here. We divided by x square and we are left with x square plus 2x plus 3. So this is our highest common factor. So when you want to eliminate the highest form, you can see that the first polynomial is a cubic. But here highest power is x power 4 and we want to eliminate. So what we do, we multiply this cubic by x so that the first term matches, and we also multiply the second equation by 2 so that the whole term becomes equal and it gets eliminated in case of subtraction. So we are left with 2x power 4 plus x cube minus 9x and 2x power 4 plus 4x square plus 18. So when you subtract, what you get x cube minus 4x square minus 9x minus 18. So when we are left with this expression, we take the remainder of the term what we got through addition, and we are going to multiply it so that we can eliminate this x cube as well. So when we are going to multiply it by multiplying with x, so you get x cube plus 2x square plus 3x. And we are going to subtract it and we are going to get minus 6x square minus 12x minus 8. Minus 6 is common, so we are going to divide it by. So we are going to understand this procedure so that we can easily get highest common factor of two polynomials. So let us take one more example. Here we take polynomials 4x power 4 plus 11x cube plus 24x square plus 17x plus 5. The other polynomial is 3x power 4 plus 7x cube plus 18x square plus 7x plus 5. So now you know that we have to eliminate both highest and lower powers. So we are going to quickly factorize them. We will see the factors. And here you can see it is really difficult to factorize this. So we are going to multiply these equations by 3 and 4 so that the first term equates. So we are going to multiply first 4x term by 3 and 3x power 4 by 4. So finally what we will be left with, we will get 12x power 4 plus 33x cube plus 81x square plus 51x plus 15. And the second term will be 12x power 4 plus 28x cube plus 72x square plus 28x plus 20. So when you subtract, the first term gets eliminated as we want, and we are left with 5x cube plus 9x square plus 23x plus 5. Now we still need to proceed till our highest common factor. So what do? We stop and we also try to eliminate the coefficient. So in order to eliminate the coefficient, you just have to subtract as is. So when you subtract as is, you get x power 4 plus 4x cube plus 9x square plus 10x. Here x is common, so you divide it by x and we get a cubic. X cube plus 4x square plus 9x plus 10. So what we will do this, both these cubics. So we are going to use both these cubics to eliminate the highest and lowest power again. We are going to multiply this x cube into 5. So and we are going to eliminate this x cube term. We are going to multiply this term and subtract it from this term so that we can get rid of this x cube term. So what we are left with? We are left with minus x square minus 22x minus 55. You can observe that the minus 11 is common here. So we are going to divide this whole expression by minus 11. So we are left with x square plus 2x plus 5. This is our highest common factor, which we will confirm again. So here we are left with a cubic and we are going to do exactly the same and we will eliminate this 10. How you will do that? You need to multiply this equation 5x cube plus 9x square plus 23x minus 5 into 2. And then we are going to add it here. So what we are left with? We get 11x cube plus 22x square plus 55x. Since x is common, 11x is common, we are going to divide the entire polynomial with 11x. And you get x square plus 2x plus 5. So this is the way how to calculate the highest common factor. Even if you come across a bit complicated polynomials, this method is comparatively really easier compared to factorization, not to mention division. Okay. So this is it, guys. Thank you very much. Thanks for listening and please post your doubts and